Hey everybody, it's verifying inverse functions day. We can have a little fun here verifying some functions, see if they are inverses or not. What we're going to do right here, all right, we're going to make f of x blue. We're going to make g of x red. Okay, so when I think blue, I'm thinking f of x. When I think red, I'm thinking g of x. So you'll notice is write simplified expressions. Oh man, they're going to make us write simplified expressions. That's just mean. For f of g of x and g of f of x in terms of x. You're like, what the heck does that mean? Well, we're going to talk about that today. All right, so we got f of g of x, and then we've got g of f of x. Now, it's really easy. All I'm basically doing is I'm taking this little red function and plugging it into the blue function. I'm taking g of x and plugging it into f of x. And then vice versa, I'm going to be taking f of x and plugging it into g of x. Now, here's the cool news. If and only if they are inverses, then f of g of x will equal just x, or g of f of x will equal x. Now, what do all inverses reflect across, everybody? All inverses, you should know this, reflect across y equals x. So that's why if you take one function and you plug it into the other function and all you get is an x, that means they are inverses. So I'm going to put inverses if this happens. If they don't just become an x, then they're not inverses. So we're going to be talking about that today. Now, it is going to be very important that you have your Desmos up, ready to go. So make sure you have your Desmos graphing calculator, all right, so we can type stuff into there while we are working on this. All right, so the first thing we're going to do is we're going to find f of g of x. That's the first thing we're going to do today. All right, we're going to say equals, and let's look right here. It has 10, right? 10x plus 6. But instead of writing 10 and then putting an x plus 6, all right, so instead of doing that, I'm going to put 10, but I'm going to open up a big old fat parentheses, and then I'm going to put plus 6 over here at the end. Do you know what I'm going to put inside of this parentheses right here? Anybody want to take a guess? No? Nope. No. I'm putting the other function, man. That's right. I'm putting this other function right in there. So I'm basically taking the red function. I'm taking this guy right here. And what am I doing? I'm plugging it in right there. That's what I'm doing. Taking one function and plugging into the other. All right, let's see what happens when we do this, guys. Let's see what happens. Hey, do you know what happens when you have a 10 in the numerator and a 10 in the denominator? You know what happens? These whoosh, whoosh, cancel out just like Johnny Karate. If you don't know who Johnny Karate is, then you don't know who Chris Pratt is, and you don't know anything. But that's okay. All right? Now, so these 10s cancel out. What am I left with? I'll bring it down in red instead of blue. I'm left with x minus 6. Ooh, does anybody know what x minus 6 plus 6 is equal to? X, because a negative 6 plus 6 cancel out, you're left with x. Wait a second. So what, in our particular circumstance, did f of g of x actually equal? It equaled an x. Now, here's the thing. Here's a quick little info to help you guys save yourself some work. I'm just letting you know, if you did all the math correctly and f of g of x equals x, then I guarantee you that g of f of x will also equal an x. And if they both equal x, which they will, this is going to be a yes. They are definitely inverses. Now, how can you check your work? How can you check your work? I will show you how to check your work in Desmos. All right, so we're going to Desmos. All right, I'm going to literally type in f of x, all right, equals, and then I'm just going to go back real quick. It says what, 10x plus 6, so I'm going to type in 10x plus 6, just like that. And then the other one was it h of x or g of x? G of x. I'll type in g of x. G of x. All right. Oh, and since f of x was blue, I'll go ahead and I'll make it blue. I'll make it blue. Okay. And then g of x equaled, and then you got this little keyboard down here. You can make a little division bar. And in the numerator, we're going to type in x minus 6 over 10. So I'll go right back over to, there we go. x minus 6 all over 10, just like that. Except this time I'll make this guy red since we made him red. All right. So there's f of x, beautifully graphed in Desmos. There's g of x, beautifully graphed. Now check this out. If they are inverses, what should they reflect across? Y equals what? Y equals x. Right now, do they kind of look like they reflect across y equals x upon first inspection? I agree, but you know what? Let's go even a step further. Watch this. F parentheses G parentheses X. Look at the green and the purple. Look at the green and the purple. Look at them. Just look at them. What can you tell me about those two? They're exactly the same, so that you know that f of g of x has to equal x. Well, wait a second, Mr. What about g of f of x? Oh my gosh. Green, purple, black. What do you notice about them? They're all the same. Now, what does that do? That gives me confidence to say, that's an X. That's an X. And are they inverses? Heck yeah, they're inverses. Boom! You got it right. Let's go to the next one. Here we go. Let's go to the next one. I'm going to highlight this guy. Now, this is g of x, and I'm going to make g of x blue. All right, making g of x blue. Okay, making him blue. And I'm going to make h of x red. Making h of x red. Now, if I were you, I'd kind of pause the video right now and just like write these guys down. Okay, because I'm going to be going over both of them. All right, so you got g of x in blue, and you got h of x in red. So everywhere I see h of x, I'm going to put a little red. And everywhere I see g of x, I'm going to put a little blue. Now, if you don't have map colors, just go down to your local store, get some map colors, get some twistables. All right, it makes it very easy to learn. The first thing I'm going to do is I'm going to do g of h of x. Now, if I'm going too fast, just pause me and catch up. It's really not that hard. Just pause. You should know the pause button. You guys are in a generation where you watch YouTube all the time. It's very easy. Just pause. So we're going to take h of x, and what are we going to do? We're going to plug it into g of x. All right, here we go. Here's g of x right here. I got a 3. I got an open parentheses. I got a 12. I got a minus in x. But what am I going to put in the place of x? What am I going to put right there? I'm going to put all of h of x, which is what? 1. I'll put it in red. Whew. It's a tough one. We got 1/3 of 12 plus x. Whew. I'm going to go ahead and pause it real quick. All right, so you're probably thinking, oh my gosh, that is just way too many parentheses. Just way too many. Okay, so what we're going to do is we're going to simplify it a little bit here. All right, so inside of this red parentheses right here, what we're going to do is I'm just going to distribute right here to both terms, and it won't take long at all. If I say, what's 1/3 of 12? That's a 4. And what's 1/3 of x? That's going to be 1/3 of, it's going to be 1/3 of x. Okay, so if I do 1/3 of 12, that's a 4, and then 1/3 of x is in x. Now I do have to multiply both of those by a negative, so here's what I have left. I'm just going to write everything in red right now, okay? I have a 3, parentheses, 12 minus 4, and then a negative minus, sorry, negative times a positive keeps it a negative, so I'm still left with 1/3 of x being subtracted. So I have 3, parentheses, 12 minus 4 is 8. All right, and if I have 8 minus 1/3 of x, whew, holy cow. By the time we're done, it looks like we got 24 minus an x, because a 3 times a negative 1/3 of x is just x. So it looks like, right now, it looks like my expression is 24 minus x, also known as negative x plus 24. Now let me tell you something. If I put negative x plus 24 right there, that is the simplified expression, but are these going to be inverses? Heck no, they're not going to be inverses, because what do we know they have to be in order to be an inverse? Just in x. Okay? Now, you're like, wait a second, how do I check to see if this is correct? Well, we're going to use Desmos. So if you would please, if you have this and this, we're going to go to Desmos right now. So let's go to Desmos. Now, I'm going to go ahead and clear this out right here. I'm going to clear this out. I'm just go ahead and clear them out. Instead of f of x, I think I'm gonna start with g of x. Let me look. Okay, g of x. So I'll put g of x, and then it was equal to 3 parentheses, was it 12 minus x? I believe 12 minus x. Okay, and then over here I'm going to do h of x equals, and let me look what it was. 1/3. Okay, got it. 1/3 parentheses 12. Was it 12 plus x? Make sure 12 plus x. Okay, so now here's the thing. Now what I'm going to do is I'm going to do our question, which was g of h of x. Okay, g of h of x, and I'm gonna keep that in I'll put that in green. Okay, now if you'll notice, we can't see it, can we? We cannot see it. However, what did we get as our answer for the simplified version? We got what? 24 minus x, also known as negative x plus 24. That's what we got. So if I put negative x plus 24, I don't see that either, do I? Do you know why I can't see it? Because we are so zoomed in, we can't see it. So I got to zoom out. Can anybody see anything about the green and the purple function? What do you notice? They're exactly the same. Now, are these inverses of each other? No, they're not. They're not inverses of each other because they don't reflect across what? Y equals x. They don't reflect across it. But are these the simplified version? These are the simplified version. So what does that tell me? That tells me right here, what am I allowed to, sorry, wrong thing. Wait a second, where am I? What am I allowed to put right here? Negative x plus 20, not z, negative x plus 24. And I'm going to put no. But the next thing I'm going to do right now is I'm going to do h of g of x. So let's go back and let's take a look at h of g of x, which means we're going to take the blue function and we got to plug it into the red function. We'll take the blue function, plug it into the red function. So if you would please, right now, we're going to go ahead and do h of g of x. So follow along. Won't take that long. Once again, I'm making this is the blue one. Okay. This is the red one. Now, if you guys would, it actually is going to make things a little bit easier. You guys see h of x? I can go ahead and distribute if I want to. So what is a third of 12? That's a what? That's a 4. And a third of x is just what? 1/3 of x. So I can write it as 1/3 of x plus 4. I can write it like that. So this will make it a little bit easier when we are taking the blue function and plugging it into the red function. So here we go. We're doing h of g of x. H of g of x equals. So watch this. I'm going to put 1/3. I'm going to open up a big old parentheses. And then what am I going to put at the end? I'm going to put a plus 4. Well, if we were allowed to distribute this 1/3 to both these to make it easier, I guess I could technically multiply both things by a 3 and make this 36 minus 3x to make it a little bit easier. So watch what happens if I just put 36 minus 3x. All I've done is simplify this g of x expression to make it a little bit easier to work with. Now all I got to do is multiply both things by a third. What's a third of 36? 12. What's a third of negative 3x? Minus an x. So now I got 12 plus 4, which is 16. 16 minus x. So I know I can put negative x plus 16, and that's going to be my simplified expression for h of g of x. So here's my simplified expression. So now we're going to go to Desmos to see if we actually did this correctly. Okay, so we already have in Desmos the two functions right here, okay? We have them, but I'm going to go ahead and delete this guy right here. But I'm going to switch the G and the H. Watch, I'm going to put this, I'm going to make this the H. All right, make that the G. And then I'm going to type in my new answer. And the new answer that I'm testing was what? Negative x plus 16. So I'm going to put negative x plus 16 and see if they match. And they do match. And since they do match, that gives me confidence to be able to type this in. Like, okay, I know now this is also what? Negative x plus 16. And I feel like now I've tested in Desmos. I'm going to get it right. Okay, if I don't test it there, I could have made some silly mistake, and Desmos will at least let me know if I messed up and made it a 15. Can you see how these aren't exactly the same? All right, but knowing that I put a 16, I know these are the exact same function. It lets me know that I got it right. Okay. All right, let's do one more, and we're going to call it a day. All right, so this is dealing with cubic. So if you would, this one says f of x equals the cubic root. I know it's kind of hard to see, but there's a little 3 in that index. So I'm going to, when I write it, I'll make sure you guys see it. And over here it says g of x equals 3x cubed minus 8. Okay, 3x cubed minus 8. So once again, the g of x will be in red, and f of x will be in blue. All right, we'll go ahead and work through this. So the first thing I'm going to do is I'm going to do f of g of x, which basically means we're taking g of x and we're plugging it into f of x. So here we go. We're going to do f of g of x. Okay. Now we got to start with this big, old, huge, I'm making it nice and big. That's an index of 3. That's a cubic root. And it's over in here, we got over a 3, and then I'm going to open up a parentheses. I'm going to put plus 8. Okay, I'm going to put plus 8. Now inside of this parentheses, I'm going to put 3x cubed minus 8. Because what I'm hoping that you will see is that normally, what did I have right there? I just had an x, but I'm taking this function right here, 3x cubed minus 8, and I'm plugging it in to the x value for f of x, and that's what f of g of x means. All right, so let's go ahead and simplify this and see what we get. All right, so what is this equivalent to? Well, up here in the numerator, what do I have? I have 3x cubed. I have a minus 8 plus an 8 all over a 3. So what do you think is going to happen to this negative 8 and positive 8? These are going to cancel each other out, right, to 0. These are additive inverses. So what do I have left now? I have 3x cubed over a 3. So what happens with these 3's? They cancel out. And then finally, I have the cubic root of x cubed. Well, what does x cubed actually mean? It means x times x times x. That's what x to the power of 3 means. So cubic roots look for groups of 3. And so this equals an x. Now, you're probably used to square roots. Like if I say the square root of 25, most of you probably say 5. If I say that what's the square root of 36, you would say 6. Why? Because square roots look for groups of what? Groups of 2, right? But cubic roots, if I say what's the cubic root of 27, not everybody is just going to spit out 3. But technically, the cubic root of 27 is 3 because 3 times 3 times 3 is 27. So what's the cubic root of x cubed? It's just x. These are just examples to help you understand what the difference between a square root is and a cubic root is. Square roots, even though you can't see it, you know what index they have? They have a 2, even though you can't see it. It's just automatically assumed there's a 2 there. But cubic roots, you got to have the index of a 3. Well, this makes my life a lot easier because what does that mean for our answer? What am I going to put here? X. What am I going to put here? X. And are these inverses? Heck yeah. Well, unless I did something wrong. So how do I test to see if I did anything wrong? What do we go to? Go to Desmos. So here we go. You're like, well, how do I type in cubic roots into Desmos? So we're going to show you guys how, okay? We're going to show you how. So go to Desmos so you don't freak out when you're like, oh my gosh, he didn't show me how to use Desmos. All right, so here we go. Let's take a look at, we have what? F of x is, let me scroll up real quick. The cubic root, got it. So I'm going to type in f of x equals, now let me show you how to get to the cubic root. You got to go over to functions. You go to miscellaneous. You go to where you have an index of n. Then you type in a 3. Then inside, you make the division bar. All right? And then you put x plus 8 over 3. X plus 8 over 3. Okay? So there's your, I don't like black. There we go, blue. We'll do blue. And we'll do, this one will be red. Okay? Then we have g of x equals, and what was g of x equal to? I believe it was what? 3x to the power of 3. And then what was it? Minus 8. Okay, minus 8. Okay? And then what are they going to be reflecting across? If they are inverses, they're going to reflect across x. I'll go ahead and make this one green. And do these even look, do they look like inverses to you right there? Do they reflect across y equals x? They look like they do reflect across y equals x. But how could you check it? F of g of x. And what do you notice? Well, it's kind of hard to see because green matches green. Or how about this? How about purple? What do you notice now? They match, right? So you could also do what? G of f of x with your keyboard. And then I'm going to change the color to orange. And what do you notice about the green, the purple, the orange? What do you notice? They're all the same. So when they're all the same, when all of these reflect across y equals x, what does that tell you? That tells you that that's an x. That's an x. And lastly, yes, they are inverses. So what do you, are you going to have this something this difficult on your 6 weeks test? You may have one problem, all right? But the main concept is this. If you get f of g of x equals x or g of f of x equals x, they are what? They are considered to be inverses. And that's the concept, all right? And then hopefully, ding, you'll get them all right. You have a good day.